Hello. Hello. Yeah. Good morning to you. Uh, for the sake of uh, our loss of the first meeting, I wish to just give you this lecture on Zoom. So when you finished listening to this video, I encourage you to try and let me know whether the sound is not clear or it's not effective enough. Because as at the time that I'm doing it, you see, it's somewhere 3 a.m. So I'm trying to reduce my voice. And if you are not clear about it, maybe I can change the time for subsequent videos so that it will always be a little bit loud. Yeah. So let me share my PPT. I'll also share the PPT with you so that always you can be going through it to see, or you'll be reading through it. So that is my PowerPoint. Right. The course name, as we all know, is CPS 111. Yeah. Computer fundamentals or fundamentals of computing. Right. So I'm Jima Kopri, as I've already mentioned to you. I'm a PhD candidate, and this year I'll be completing my PhD course. Fine. So welcome once again. So let's see. Let's go to the next slide. Now, this is the course description. So this entails the basic things that we'll be doing. We're talking of some few hardware devices and software. So as you knew from SHS, when we take a computational system or a computer, it has mainly two sections, which is the hardware and the software. So within the hardware, or within the software, we have what? We have the operating system, the application, and other things like utility softwares. Yeah, so when you take the hardware too, we have things like the central processing unit, the motherboard, and peripherals. So some of these things I may be showing you in class, or I may be doing some videos and be showing to you. So this is just to tell you what the course entails. Fine. Now the objectives. What do I want you to do? So at the end of this lesson, I want all students to be able to understand computer hardware and software. And the way we represent data, you see, the way the computer communicates is not like humans. Humans, we use our English alphabets, English words, phrases, and sentences. But the computer does something different. It uses specifically numbers to do its own communication. And at the end of the day, too, you should be able to create and edit Word documents and explain data communication while building computer networks. Because at the end of the day, when you are given a document to type or to edit, let me say you are asked to type a letter, you should be able to put it in a format that follows the Microsoft Word criteria. I know some of you are aware of it, but then if you are not aware of it, you are here to learn, and I'm going to take you through that. And finally, you'll be doing data communication. What do we mean? If you have a computer A and you want to communicate information from that computer A to computer B somewhere, this is where your networking and your telecommunication or your communication comes in. So you'll be dealing with that one too in accordance. So let's go to the content. I think the content, I'll allow you to read it yourself. So let's just jump into action. So our first point to talk about is introduction to computers and computer science. You see, this course is specifically created from the computer science point of view. So we will first of all look at the computer. The computer itself that you have, or the computational system, have four main sections. And always when I go to class, I try to add the third, the fifth section. But basically, we have the inputs. So don't forget, we have the input. That is where we always put our data. Then when the input gets into the what? When the data gets into the process or the central portion, something is done to it, or there will be some kind of processing. After it has been processed, it will either come out through the output device or it is stored as a stored information. So basically, this is what every computational system does. Now, if I have another computational system somewhere and I want to communicate whatever that I've processed to that computer, that is where our networking comes in. Yes, so that becomes the fifth aspect of it. But for the basic definition, we say that the computer comprises four basic sections. As simple as that. Good. So let's go to our next point. Let's look at core characteristics of a computer. You see, when a computer came into our human life, it was able to bring various characteristics that made it to be able to what? To penetrate through the technological landscape. One, it has speed. You see, the speed at which you use a computer to execute some kind of task is very high. So you see that it operates in nanoseconds or billions of what seconds. So it's about 1 divided by billions of seconds. So the time is very, 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 very small, infinitesimal. So this one, we are looking at the speed at which the computer executes instructions or execute a task. Now we go to accuracy. You see, as compared to humans or manual, when a computer does something, we see that the accuracy is always high. On the other hand, we see that the errors that are made by a computer are always smaller or are always less as compared to manual systems or human systems. Now, what about diligence? You see, if you want someone to draw the picture of, let me see, uh, the VC. If I give you papers to draw VC, you can draw it all right, or you can draw him all right. But if I tell you to draw him again, you see, there will be a lot of differences. But then if it is a computer that did that drawing, the computer can repeat it billions of times without any difference. So, and the speed at which it will do it to is higher than what the humans will do. Yes, so that is why we say it is diligent. Then we look at versatility. You see, when you say somebody is versatile, it tells you that a person can do different type of task. So we can use it to do text, graphics, calculations, a lot of things. So the computer can perform different type of jobs or different type of task. Then storage capacity, the amount of memory that the computer has is far, 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 far bigger than what the human being can carry. You see, a whole library can be stored on the computer, or billions of songs can be stored on a computer, and the computer will replay everything. But I don't think any human can do that. Yes, then we talk of automation. It can work automatically once given instruction. You see, you can give a computer instruction and it will start doing whatever that you have instructed it without always human intervention. Fine. So, having said that, let's try to see how the computer history started. We call a particular era or an age, we call it the pre-electronic era. At that time, all the computers there were not electronic. Tells you that it was not electronically inclined or they were not digital systems. They were just mechanical systems. So example is the abacus. So when you look down there, we have the picture of the abacus. And this one, I think our current primary school students have been using it. We use it for computation. So this one is believed to be the first computer that was invented. Then we go to the Pascaline mechanical calculator. So all these things too were mechanical devices that were there for doing calculations. Then the Babbage analytical machine, which is the middle one. You see, it was ruled or it was performed with mechanical strength. You see, somebody have to stand there and be rotating some wheels. So I urge you to go online to YouTube, type Babbage analytical machine. Then you look at the video of how it was used. So it has a lot of gears, a lot of looms, a lot of what? Mechanical systems. So that was many, many, many years ago. So the right-hand side, the one here is the ENIAC. That is where we entered into the first generation of what? Digital machines. And by then, we were using vacuum tubes. So one day I have to come to class and show you the difference between transistors, solid state transistors, and vacuum tubes. So the vacuum tubes were bigger. They were big like bulbs. The onion bulbs, the one that you have in the kitchen. But it got to a point we have to replace it with solid state transistors and ICs. So I'll come to class and show you. So there that we started to give birth to the first generation of what? Electronic computers. And the first one that we believed to be an electronic computer was the ENIAC, UNIVAC, and the rest. So the ENIAC means electronic numerical integrator and what? Computer. Please try and memorize this because it is examinable. So how it was created, it was very big. Power hungry means it consumed a lot of power, and more to it too, it was generating a lot of heat. So that was the first generation. So one day you'll be asked to explain the first generation computer, and you should be able to tell us something about the what? The ENIAC. Now, we continue with our history. So the second generation was born, and that is where we brought in transistors, solid state transistors, to come and replace these vacuum tubes. And it was smaller in size, it was faster than the ENIAC, and it was more reliable. And an example is the IBM 1401. IBM 1401. So that is it over there, over here, the IBM machine. So we go to the third generation. That was between 1960s to the 70s. Here we were using integrated circuits instead of transistors. As I said, there's a difference. I have to come to class and show you. There's a difference between a transistor and an IC. IC is an integrated circuit. Most of you might have heard of it, and it came to replace the transistor-based computer. And that one has multiple transistors. Within an IC, we what? Embed millions and hundreds, thousands and millions of our transistors in it to make it one unit or module. So here we have the silicon chip spearheading everything. So that is where we give birth to mini computers. And an example is the PDP-8. Fine, then we went to the fourth generation, somewhere within the 1970s to our present time. So in there, we don't have an IC. We rather have a microprocessor. So I have to come to class and show you a microprocessor or a microcontroller. And I may even ask you to program it yourself. What do we mean by programming? Trying to give instruction to a metal so that the metal will do what you said it should do. So at the end of the day, if I want a music to play when I clap my hand, I have to be able to write that instruction and give it to the microprocessor. Yes, and there's a special way of doing that. One day I'll just come to class, demonstrate it with my TA so that you understand what we are talking about. So in there, we talk of a CPU on a silicon chip or a single chip. So look at the way the transition was made. We said at first they were what? Mechanical systems. Then the first generation came, we're having vacuum tubes, second generation transistors, third generation integrated circuits, then the fourth generation microprocessors. So example of these PCs are just personal computers that we are having today, IBM PC, Apple, Macintosh, and all those kind of things, Lenovo and whatever. Now, there is another generation. We call it the fifth generation. For the fifth generation, it focuses on artificial intelligence. And that is why these days you can use some of these computers to do something like Chat GPT. I don't know whether you've heard of Chat GPT, artificial intelligence, Chat GPT, DeepSeek, and other things. Then quantum computing. These are special areas that people are what? People are specializing. Parallel processing and natural language processing. As for natural language processing, you've been using it like this ChatGPT and the rest. So the trend is ubiquitous what? Computing. So at the end of the day, we should be able to have other things that are not computers to also communicate with us, like mobile phones, CCTV cameras, and the rest. You see, other things are coming in which are not computers, but they can perform their jobs like computers, as I've shown you, tablets, phones, watches, and others. And we are having cloud computing too. This time you can be in Ghana and you'll be streaming a video from America. This is the use of what? Or this that's the power of cloud computing. You can be somewhere and you can be accessing something from elsewhere. That is based on what? Cloud computing. Through the internet is when you do that. Then you have supercomputing. And through the help of what? Supercomputing or computers that are highly powerful. That is why you are able to be served at the same time. Because you see, if you are watching a video from YouTube, you are actually watching it from a particular PC, or you are taking it from a particular PC, which is hiding somewhere in America or UK or whatever. But then you should know that you are not the only person receiving that video at that point. You see, other people are also receiving it. So how does that computer over there serve all of you at the same time? If the computer is not a supercomputer, it will not be able to do that. So in this fifth generation, we say that the goal is to develop machines that can reason and learn like humans. So our computers are becoming very, 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 very intelligent. So we have the images of our AI, cloud. We have what? Smartphones and quantum what? Computer symbols. So that is it. Now let's go to computer science. You should be able to know what computer science is. Mm. People think computer science is just about programming. No, it doesn't go that way. Mm. It's a systematic study of doing certain things. What are they? Theory, experimentation, and what? Engineering. You see, you should be able to know the theory behind the computer. You should be able to know how to experiment with the computer and how to engineer. What is the meaning of engineering? Picking a particular technology to solve a particular issue. That is engineering. That forms the basis for what design and use of what computers. And there you'll be talking of algorithms, the step-by-step way of solving a problem. You see, if you are given simultaneous equation to solve, there is a way of going by it. You start with the first stage, go to the second stage, you do all those things before you finish. So if tomorrow you want a computer to solve simultaneous equation for you, it's the same process that you are going to describe the algorithm for the computer so that it will solve it. And that is what we call algorithm. Step-by-step procedure for solving a problem is algorithm. So let me remind you this. The next time that I come to class, it's possible I'll conduct a class test because I'll make sure you guys have watched this video very well and you memorize certain things very, very, very well. Then we talk of data structure. You see, the data that we are feeding onto the computer is good. We organize it very well. You see, as let me use human beings for instance. If you have a child in the house and you want to feed something to the child, it's not any time that you give the child anything. If you are feeding the child with food and you see the food is choking, I don't think you add the food again. You now give water, right? Sometimes too, if you realize that the child is sick, what you rather put there is medicine. So that is the same thing with the computer. The computer also take certain data differently in certain times. So you have to organize all of them. So it's not every time that you give a particular data to a PC. So you have to sort and organize them very well before they get in. Right. So let's look at key areas within the computer science field. Within here, but it's the same as IT. That's why we are adding it. So you do software engineering, That one, you design and build a reliable software system. So I told you I'll let you build a software. Definitely, I'll already let you write your own code or you write your own software. Then artificial intelligence too is also one key area of computer science. And they are meant to add creating intelligent machines and softwares to make the computer to now think like a human. Fine. Then we have network and security. Some of you will go into networking, how to connect computers. Fine. Then database systems, how we can store data, manage it, and also retrieve and use it. The human computer interaction. You see, there are websites, there are softwares, and there are what? App that people are building. You see, you open somebody's app and you see that, yeah, this app is very nice. So there are some people who are also trained to do that and they do it to be user friendly. Whilst it is nice, it is also what responsive. You click something, it goes faster for you and all those kind of things. Fine. Then we have theory of computation. Here, we use mathematical foundations to describe these algorithms and the complexity of how the computer works. Okay, then significance and impact of computers. You see, when computers came into our lives, what are some of the impacts or what are some of the what significance or importance? You see, they've revolutionized our way of communication. You see, today, because of social media, you can just press a button, but then an information will move from your PC or your phone to somebody elsewhere in the world. So we have emails, social media, and what video conferencing. Right. Then secondly, it transforms our industry. You see, our banks, at first, before you cash out some money, you have to go and queue in the bank. But today, due to mobile money and all those kind of things, things have changed. Then our healthcare, today too, we can use computers to monitor a lot of things in the world, in the hospitals. Entertainment, you see, the way we get our football streaming, our singing artists, the way we interact with them, all those things have changed, and our transportation over there too. Computers have what changed a lot of things about that. It enables globalization. So instant access to information. You see, somebody can be talking in US now and you can be streaming it live. Or there can be some football going on, match going on, and you can be streaming it live. Advanced scientific research. So these days we have simulation. There can be a way that you can even play football without actually wearing a boot and playing on the field. You can use keypads and just be playing the football on the screen, and it will look real, like what is happening on the field. Then we have data analysis. Sometimes we have to pick data and we get insight out of the data. Then we create new fields. So through this that we had data science, cybersecurity, and what digital forensics. So I think this cybersecurity, before you complete, we have to introduce you to it. And students normally like this course because some of them want to use it to hack. But please, you have to clear that thing from your mind. You are not supposed to hack. Let me give you an analogy. Uh, I don't think if you are somebody who is a doctor operating somebody or having performing surgery on somebody in the theater, you see, when you are being surgeries performed on you, you are always naked. You, the one that they are operating on, you are always naked. But I don't think it's the nakedness that you are going to concentrate on when you are operating somebody. No, you are in there to solve a problem. So that is how an IT person should behave. And I always tell my student, please, if somebody's computer has a problem and he gives it to you to repair, he trusts you. So there's something we call computer ethics. Follow it. Don't open any folder on the person's computer if you are not what allowed to do that. So you have to keep those ethics and you keep your what integrity, respect, and what trust. So that is it for that. So that is cybersecurity. We are going to do it. Then it empowers individuals, access to knowledge. So today you can get knowledge from sites on the internet. Gone are the days you'll be asking people about how to do certain things. But today you just go online, you search, then get it. Tools for creativity and what remote work learning, work and what learning. You see, I can be somewhere and I can be teaching you at the same time. Yes, and today look at what we are doing. I'm just going to do this and I'll give it to you remotely. and you enjoy. Fine. So we go to the next one, that data representation and number systems. I think I'll have to stop here because I don't want to load you much. And when I come, I'm going to examine you on what I've already taught you. And if you have any problem, please paste it on the page. I'll answer you immediately. Thank you.